Hello guys, welcome. Today we'll be looking at this room on Introduction to Cryptography. This is a free room on TryAcme and it's going to teach us about the encryption algorithms such as the AES, the Diffie-Hellman key exchange, hashing, PKI, and TLS. This is a medium room and it is supposed to take about 240 minutes. We can't take this at once, so we are going to split the rooms into short videos, maybe 20 to 30 minutes, depending on how packed it is. I've completed this room, so I'll be resetting my progress and we'll be starting. The purpose of this room intro is to introduce users to basic cryptography concepts such as symmetric encryption such as AES, asymmetric encryption such as RSA, Diffie-Hellman key exchange, hashing, and PKI. Suppose you want to send a message that no one can understand except the intended recipient. How would you do that? One of the simplest ciphers is the Cipher cipher, which has been used about 2000 years ago. The Cipher cipher shifts the letter by a fixed number of places to the left or to the right. Now, we consider the case of shifting by 3 to the right to encrypt, as shown below. So if the recipient needs to decrypt it, they shift to the left by 3. And that's why if you shift A to the right by 3, you have D. If you are reversing it by decryption, you shift D to the left by 3, you have A. So using the same key to encrypt TryAcme, we get WB, KDFN, and PH. The Cipher cipher that we have described above can use a key between 1 and 25. With a key of 1, each letter is shifted by 1 position, where A becomes B and Z becomes A. With a key of 25, each letter is shifted by 25 positions, where A becomes Z and B becomes A. If you move it by 20, that means like going direction of -1. Now, a key of 0 means that there is no change. Moreover, a key of 26 will also lead to no change, as it will lead to a full rotation. Consequently, we conclude that Cipher cipher has a key space of 25, that is, there are 25 different keys that the user can choose from. Let's consider the case where you have intercepted a message encrypted using Cipher cipher, such as what we have here. Then we are asked to decrypt it without the knowledge of the key. We can attempt this by using brute force. That means we'll try all the possible keys and see which one makes the most sense. In the following figure, we notice that the key being 5 makes the most sense. That is, this is Alpha Bravo contacting Tango Hotel Mike. That's if you use the key 5. You can see key 1, key 2, key 3, key 4, key 5. Right? Now, Cipher cipher is considered a substitution cipher because each letter in the alphabet is substituted with another. Another type of cipher is called Transposition cipher, which encrypts the message by changing the order of the letters. Let's consider a simple transposition cipher in the figure below. We are going to start with a message. This is Alpha Bravo contacting Tango Hotel Mike, and the key is 42351. After we write the letters of our message, as you can see the way we've written it, by filling one column after the other rather, we arrange the columns based on the key and we then read the rows. We've written this is Alpha. Can you see Bravo? Can you see how we've written it in each of the columns? Yeah. So we are going to write by columns and read by rows. The key is 42351. And so we read 4 first. That's N. 2, that's P. 3, C. 5, 0. Or rather, then 1 is T. And that's what we have here. The next row, G. 4, 2, H, as we have here. 3, That's O, 0, right? 5, that's T, and 1, that's H, right? So now, in other words, we are going to write by columns and we are going to read by rows. Also notice that we ignored all the space in the plain text in this example. So the resulting cipher text is going to be this gibberish, and we will now read it one row after the other. In other words, a transposition cipher simply rearranges the order of the letters, unlike the substitution cipher, which will substitute the letter without changing their order. I hope that makes sense. So these tags introduce simple substitution and transposition ciphers and apply them to messages made of alphabetic characters. For an encryption algorithm to be considered secure, it should be infeasible to recover the original message, that is, the plain text. In mathematical terms, we need a hard problem, that is, a problem that cannot be solved in polynomial time. A problem that we can solve in polynomial time is a problem that is feasible to solve even for large inputs, although it might take the computer quite some time to finish. If the encryption message can be broken in a week, the encryption used will be considered insecure. However, if the encrypted message can be broken in 1 million years, the encryption will be considered practically secure. Let's consider the monoalphabetic substitution cipher. Mono as in one alphabet, right? Where each letter is mapped to a new letter. For example, in English, you would map A to one of the 26 English letters, right? Then you map B to one of the remaining 25 English letters, and then map C like that, like that. So we might choose the letters in the alphabet to be mapped to this respectively. In other words, we know that A becomes X, B becomes P, and so on. The recipient needs to know the key to decrypt the encrypted messages successfully. This is like when we say we are using the same key to encrypt and decrypt, right? That's what we are doing here. This algorithm might look very secure, especially since trying all the possible keys is not feasible. However, different techniques can be used to break a cipher text using such an encryption algorithm. One weakness of such an algorithm is the letter frequency. Listen attentively. It's not hard, really, just pay attention. So, in English text, the most common letters are E, T, and A, as they appear at a frequency of 13%, 9.1%, and 8.2%, respectively. Moreover, in English text, the most common first letters are T, A, and the O, as they appear at 16%, 11.7%, and 7.6%, respectively. Now, let's add to this the fact that most of the message words are dictionary words, and you'll be able to break an encrypted text with the alphabetic substitution cipher in no time. We don't really need to use the encryption key to decrypt the receipt cipher text, as shown in the figure below. Using a website such as QuickQuip, it will take a moment to discover that the original text was "The man who moves a mountain begins by carrying away small stones." Now, what this is saying is that most of these methods that have been around since ages, you have tools now that can easily decrypt them. Whatever you are using as an encryption method, as long as it can be decrypted within a week, few days, few hours, then it is insecure. Do you get? So this example clearly indicates that this algorithm is broken and should not be used for confidential communication. Now you have received the following encrypted message. You can guess that this is a quote. Who said it? Right? So let's look at the int. We are supposed to use quip quip. So we copy this, open link. Excuse me. And we are going to copy this. Okay. Copy. Let's see if quip quip is here. We're going to paste. And we are going to solve. Okay, we can see Today is victory over yourself of yesterday. Tomorrow is your victory over lesser men. Just imagine few seconds, just few seconds, you are done. This is not secure, right? So who said this? This is Miyamoto Musashi. I'm gonna copy this. We are going to impute it here. Submit. Great. So with this, we've come to the end of this lesson. We looked at a very weak encryption method. Basically, we are using the transposition cipher and the substitution method. We have the Cipher cipher, which has been used about 2000 years ago, which is a substitution cipher that requires you to shift your letters by a fixed number of places. And the transposition cipher requires you to write by columns and you read by rows using a key. Now, these are weak ciphers because it takes few seconds, maybe minutes, to decipher them, to decrypt them rather, and they are considered insecure. If you need to transfer information that is confidential, these are not the best ways to do it. And we have a tool called QuickQuip, which is an automated cryptogram solver that can easily solve any puzzle cryptography that you find. Thank you very much for listening.